In my last video, we have discussed the differences between homogeneous catalysis and heterogeneous catalysis. When the catalyst and the reactants are in the same phase, the catalyst is called homogeneous catalyst and the process is called homogeneous catalysis. But when the catalyst and reactants are in different phase, the catalyst is called heterogeneous catalyst and the process is called heterogeneous catalysis. Okay students, this heterogeneous catalyst usually exists in solid state. Okay, today I am going to explain the mechanism of heterogeneous catalytic reactions. How a heterogeneous catalyst, how a solid catalyst, okay, can increase the reaction rate. Please listen. The mechanism of heterogeneous catalysis can be explained on the basis of a very important theory, that is modern adsorption theory. Okay, this modern adsorption theory is a combination of old adsorption theory and intermediate compound formation. Yes. Okay students, please listen. The heterogeneous catalysis is regarded as a surface phenomenon in which the catalytic activity, the activity of a catalyst is localized on the surface of a solid catalyst, surface of a heterogeneous catalyst. The surface of the catalyst has free vacancies. Okay, the surface of a catalyst has free vacancies which adsorb, okay, or which provide sites for chemical reactions. Okay students, the free vacancies present on the surface of a solid catalyst provide the sites for chemical reactions. Okay, this heterogeneous catalysis involves okay, the following steps. Please listen. The first step, I already told you, the heterogeneous catalyst exists in solid state. Then the reactants may be exist in gaseous state or in the form of solution. Okay, suppose the reactants exist in gaseous state. The first step, please listen, diffusion of the reactants. Diffusion of the reactants to the surface of the solid catalyst. Okay, the reactant molecules, the gaseous reactant molecules diffuse slowly to the surface of a solid catalyst. It is the first step. Second step, please listen. Here A and B act as gaseous reactants. This one indicates a catalyst surface having free vacancies. Then second step, adsorption of molecules of the reactants at the active site. Please listen. The active site or the vacancies of the solid catalyst adsorb the gaseous reactant. That is the second step. Okay. Then here the third step, chemical reaction takes place on the surface of a solid catalyst. Here the reactant A and B undergo chemical reactions. So chemical bond is formed between A and B and the surface of catalyst. Okay, this is the third step, occurrence of chemical reactions on the surface of catalyst. Then here yes, a bond is formed between A and B and okay, then the next step, that means here an intermediate is formed, and the next step, okay, catalyst involves the formation of intermediate, okay, then what is the third step? Occurrence of the chemical reaction on the surface of catalyst through the formation of intermediate. Here an intermediate is formed, reaction intermediate is formed. Okay students, then the next step means fourth step, desorption of the product molecules. The product AB get desorbed from the surface of the catalyst. Desorption of the product molecules from the surface of the catalyst. Okay, and the final step, diffusion of the product. Diffusion of the product, okay, away from the surface of the catalysis. Then please listen, the main steps involved in heterogeneous catalysis. Number one, please listen, diffusion of the reactants to the surface of catalyst. Number two, adsorption of the molecules of the reactant, okay, at the active site. And the third step, occurrence of chemical reaction on the surface of catalyst through the formation of intermediate. And the next step, desorption of the product molecules from the surface of catalyst. As fourth step. Then fifth step, diffusion of the products from the surface of the catalyst. Okay students, in my next video I will discuss very important topic, okay, shape selective catalysis. Okay, goodbye, study well.